Module, we will cover the electrical system of the ATR. We'll start out with a brief system description. Following the system description, we'll cover the DC system, the AC constant system, the AC wound system, and the external power. Finally, we'll review the controls and indicators associated with the electrical system. The electrical system on the ATR consists of the main and emergency batteries, two engine-driven starter generators. In this module, we will cover the electrical system. The electrical system on the ATR consists of the main and emergency batteries, two engine-driven starter generators, and two AC wound frequency generators. AC and DC electrical power can also be supplied by an AC and a DC external power unit. These receptacles are located on the right side of the fuselage, on the first officer's side of the nose gear. Two static inverters can convert DC power into AC power at a constant frequency. When operating, the inverters will power the respective AC bus. The DC electrical system can be powered by the AC wound generators through a transformer rectifier unit, or TRU. This TRU converts 115 volts AC into DC power. The electrical system is divided into the left and right networks. These two networks normally operate independently, but can be connected together through bus tie contactors in the event of a failure. The controls and indicators for the electrical system consist of a main electrical power control panel located on the overhead panel. A simplified schematic of the electrical system is etched into the panel. There is an indicator panel located on the lateral maintenance panel located on the captain's side panel. DC voltage and current can be checked by means of a rotary selector. This panel is normally used by maintenance and is protected with a transparent cover to prevent operation of the panel while the aircraft is in flight. A panel located on the aft portion of the co-pilot's side panel provides malfunction information, again, primarily to be used by maintenance. The electrical system logic is controlled by the Bus Power Control Unit, or BPCU, located in the avionics rack behind the first officer's seat. Two independent BPCUs control the AC and DC systems, one for each system. The BPCU controls the configuration of the electrical system by controlling various contactors. These contactors include the DC and AC wound bus tie contactors, the battery start contactor, load shedding through the utility bus contactors, AC and DC external power control functions, as well as the DC and AC service bus contactors. The 28 volts DC system is normally powered by two engine-driven starter generators or an external ground power unit. Two batteries provide a source of power for emergencies or for when the aircraft is on the ground without the engines running and no external ground power unit. The DC distribution system consists of a hot main battery bus and a hot emergency battery bus, two main buses called DC Bus 1 and DC Bus 2, a DC emergency bus, a DC essential bus, a DC standby bus, two utility buses, a DC service bus, and a ground handling bus. DC Bus 1 and DC Bus 2 are normally powered by their respective generator. The aircraft operating manual lists all the systems are powered by the DC buses. The DC emergency bus and the DC standby bus are normally powered by DC Bus 1 through the hot emergency battery bus. If one of the two batteries has a thermal runaway, the battery charge contactor will open and the associated bus will be transferred to DC Bus 1. If DC Bus 1 is not powered, then a main bus transfer contactor will close, which will cause the associated bus to be powered by DC Bus 2. If neither DC bus is operating, the DC emergency bus and the DC standby buses will be powered by the transformer rectifier unit, or TRU, if it is operating. The TRU converts AC wound power into DC power. This will be covered later in this module. If the TRU is not operating, then the DC emergency bus and the DC standby bus will be powered by the hot emergency battery bus. The DC essential bus is normally powered by DC Bus 2 through the hot main battery bus. Again, if a battery has a thermal runaway condition, the DC essential bus will be powered directly by DC Bus 1 if it is operating. If DC bus 1 is not operating, the DC essential bus is powered by DC bus 2 through the main bus transfer contactor. Two utility buses power non-essential loads. These utility buses are powered by their respective DC bus through a utility bus contactor. These contactors are controlled by the BPCU. These utility buses are automatically shed in the event of an overload of the DC buses. There are two batteries on the aircraft. One battery is called the main battery, and the other is called the emergency battery. The main battery is a 24-volt NiCad battery, which is rated at 43 amp hours. The emergency battery is a 24-volt NiCad battery that is rated at 15 amp hours. The main battery is normally used for engine starting. This battery is also a source of emergency power. The emergency battery has two functions. Its primary function is to ensure that the emergency electrical network is powered even if the main battery is depleted. This could occur if an engine fails while in flight and multiple restart attempts deplete the main battery. The second purpose of the emergency battery is to prevent power transients on critical equipment during engine starts. The emergency battery does not supplement the main battery during engine start. The multifunction computer monitors the status of the batteries. If either battery requires charging, the multifunction computer will connect the affected battery to the associated DC bus to allow it to charge. In addition, the multifunction computer will monitor the charge current and the associated DC bus voltage to prevent a battery thermal runaway condition or an abnormal battery operating condition. Each battery is connected to an associated hot battery bus. One bus is called the hot emergency battery bus, and the other is called the hot main battery bus. As the name implies, these hot buses are always powered as long as the associated battery is charged. It should be noted that under normal conditions, the hot battery buses are normally supplied by the DC buses. The hot emergency battery bus is powered by DC bus 1, and the hot main battery bus is powered by DC bus 2. When the DC system is operating normally, the items powered by these buses will use normal DC power instead of battery power. The voltage and current of each battery can be checked on the lateral maintenance panel by placing the selector knob to the battery main or emergency position. These two indicators read the information from the associated hot battery bus. A ground handling bus is connected to the hot main battery bus through a battery transfer relay or BXR. If the main battery is charged, the battery transfer relay will close if the cargo door operating panel door is opened, if the refueling panel access door is opened, or if the entry door is opened. Once the relay is closed, the ground handling bus will be powered by the main battery. The battery transfer relay will close under the specified conditions regardless of the position of the battery switch. The ground handling bus is also powered when external power is available. When external power is available and of acceptable quality, the external ground handling relay closes and the battery transfer relay opens. This will cause the external power supply to power the ground handling bus through the DC service bus provided the flight attendant ground service bus push button is in the on or pressed in position. You should note that the powering of the ground handling bus does not require external power to be selected on. The ground handling bus powers items to service the aircraft while the aircraft is on the ground. The ground handling bus provides DC power to the fueling controls and indicators and the cargo door control and indicators. Since these are not required in flight, the ground handling bus is de-energized when the aircraft is in flight. The DC service bus supplies power to the galleys, lights, the lavatory system, and the auto feather pump manual control. This last feature is used to perform tests when the aircraft is on the ground. The DC service bus is powered either by DC bus 1 or external power. If external power is available, the power to the DC service bus is controlled by the DC service bus push button located on the flight attendant panel. When this push button is depressed, the DC service bus is powered through the service bus transfer relay. Click on the DC service bus push button to power the DC service bus. If DC bus 1 is powered, then the service bus is controlled by a switch on the overhead panel labeled DC Service Utility Bus. This button gives the flight crewmaster control of the ground service bus DC push button on the flight attendant's panel. When the engines aren't running, the DC system can be powered by the battery system. The battery toggle switch is used to power various DC buses using battery power only. Click on the battery toggle switch to continue. When the engines are not running and external power is not available, the on position of the battery switch will supply DC power from the hot main battery bus to the DC essential bus through the hot main bus transfer contactor. In addition, the hot main battery bus powers the DC standby bus through the standby bus transfer contactor and inverter 1 through the hot battery transfer contactor. In addition, the hot emergency bus will supply DC power to the emergency bus through the hot emergency bus transfer contactor. This configuration is known as basic mode. If external power is plugged in, the available caption will illuminate if the bus power control unit determines that the power output of the external power cart is within limits. With the available caption illuminated, the DC external power can be connected to the DC electrical system by pressing the external power push button. Click on the external power push button to continue. When external power has been selected, DC bus 1 and DC bus 2 will be powered by the external DC power. In addition, the associated utility DC bus will be powered through a contactor. It should be noted that in this scenario, DC bus 2 is powered by external power through the bus tie contactor, provided that the bus tie contactor push button is in the normal or released out position. When DC bus 1 is powered, the static inverter override transfer contactor closes and the hot battery transfer contactor opens. This transfers the power source for inverter 1 from the hot main battery bus to DC bus 1. Charging of the batteries can be enabled by means of the two battery charge push buttons. Battery charging is enabled when the associated push button is in the pressed in position. This will cause the associated battery charger contactor to close and allow external power to recharge the associated battery. Battery charging is controlled by the multifunction computer. This function will be covered later in this module. When external power is supplying the DC system, the standby bus transfer contactor will change the power source for the DC standby bus from the hot main battery bus to the hot emergency battery bus. When DC bus 1 is powered by a generator and external power is removed, the service select bus relay closes and the service bus transfer relay opens. This shifts the source of power of the DC service bus from external power to DC bus 1. When the engines are running, DC power is supplied by two DC starter generators. These generators function both as a starter during engine start and as a DC generator when the engines are running. The DC starter generators are driven by the associated engine accessory gearbox. When operating as a generator, these units produce between 27 to 31 volts with a nominal setting of 30 volts. They each output a nominal 12 kilowatts of power. The generators are cooled by air. When an engine is started, a start contactor connects the associated starter generator to either the main battery, DC external power, or the main battery and the opposite generator if it is operating. During a start, both battery charge contactors will open in order to isolate the emergency battery bus from DC bus 1 and the hot main battery bus from DC bus 2. Therefore, the DC standby bus will be supplied by the hot emergency battery bus, and inverter 1 will be powered by the hot main battery bus. This is done to prevent power transients during the engine start. During this sequence, both emergency power indicators will illuminate. If only battery power is available and none of the engines are running, the starter generator is powered by the main battery through the battery start contactor. If external power is available and none of the engines are running, the starter generator is powered by DC external power through the external power contactor. Once an engine is running, the second engine is connected to the main battery and the operating generator, provided the aircraft is on the ground. This is called a cross start. During a cross start, the main battery turns over the starter on the starting engine until NH reaches 10%. At that point, the generator on the running engine will connect to the start bus automatically to assist the start until NH reaches 45%. If a cross start fails for any reason, an amber cross start failure light will illuminate, a single chime will sound, and electricity will show on the cap. The electricity light will go out at 45% NH. During all starting, when the engine speed reaches 45% NH, the start contactor opens and the starter generator is no longer cranking the engine. When an engine reaches 61.5% NH, the starter generator acts as a generator. The transition between the start mode and the generator mode is controlled by a Generator Control Unit, or GCU. This GCU opens the start contactor at 45% NH and closes the generator contactor at 61.5% NH to allow the starter generator to act as a generator. The GCU maintains a constant voltage output and provides fault protection and detection for over or under voltage, over or under speed, differential fault current, generator overload, power and fault current limiting, bus tie lockout, reverse current, and equalizing load. When a generator is operating, the associated DC bus will be powered through the associated generator contactor, provided the associated DC generator push button is selected in and external power is not used. External power has priority over the engine generators. Therefore, in order to get the engine generators to power the DC buses, the external power push button has to be selected off. This will open the external power contactor and close both generator contactors. If only one engine is operating and external power is selected off, the operating generator can power both DC buses through the bus tie contactor. This contactor will automatically close provided the bus tie contactor push button is released out. The released out is the normal position of this push button. The position of the contactor is indicated by the green flow bar. This bar is visible when the bus tie contactor is closed. If the flow bar is green and the bus tie contactor push button is then depressed, the button will show isolate in white with both sides of the system then operating independently. After the second engine is started, the bus tie contactor will automatically open, and each generator is now supplying its respective side of the DC system. The green flow bar will then extinguish. The constant frequency AC system consists of a 115 volts AC network and a 26 volts AC network, power supplied by two inverters that were discussed earlier in this module. Each inverter is normally powered by the associated DC bus. The inverters require DC power within a range of 18 volts DC and 31 volts DC in order to operate satisfactorily. Each inverter produces 115 volts AC and 26 volts AC at a frequency of 400 Hz. AC power produced by the inverters is single phase. The 115 volts AC system supplies AC power to systems such as the smoke detector fans and the digital flight data recorder. The list depicted on this screen identifies a system using 115 volts AC power. The 26 volts DC system supplies systems such as the flat position indicating system and navigation course and heading selection. The screen depicted here shows all the systems that use 26 volts AC power. The 115 volts AC network consists of two AC buses called AC Bus 1 and AC Bus 2 and an AC standby bus. During normal operations, Inverter 1 powers AC Bus 1 and the AC standby bus. Inverter 2 powers AC Bus 2. The two 115 volts AC buses are connected through an AC bus tie relay, which will close automatically in the event one of the inverters fails or is not powered. In the event of a failure on Inverter 1, the AC standby bus will be automatically powered by Inverter 2. The 26 volts AC system similarly consists of an AC Bus 1, AC Bus 2, and the AC standby bus. The arrangement and operation of the 26 volts AC system is the same as the 115 volts AC system. Some systems on the aircraft are high-draw items and require a different source of AC power. This source is called the AC Wild system, which is powered by two propeller-driven AC generators. These brushless generators are air-cooled and deliver 20 kilovolt amps. The reason these generators are called Wild is because they will produce between 115 to 200 volts of power at a frequency that ranges between 341 and 488 Hz. The frequency depends on the propeller speed. Each AC Wild generator is controlled by a Generator Control Unit, or GCU. The GCU protects the electrical system against faults in the AC generator Wild system. Fault protection is provided for overvoltage, undervoltage, power and fault current limiting, bus tie lockout, differential fault protection, overfrequency, underfrequency, and open phase. In addition, the GCU regulates the voltage output of the generator. Each AC Wild generator powers an associated AC Wild bus through a generator contactor. The GCU will open the contactor in the event a fault has been detected. In the event of a fault, an AC Wild bus will be automatically powered by the opposite AC Wild bus through two bus tie contactors. AC external power can power both AC Wild buses. AC external power is plugged into the airplane electrical system through a receptacle located on the right side of the aircraft, just aft of the nose gear. If AC external power is plugged in, the bus power control unit will check the quality of the AC power supplied by the external cart. If the AC power is within limits, the available caption in the AC Wild external power push button will illuminate. External power is then connected to the AC Wild system by pressing on the push button. Click on the external power push button to continue. AC external power has priority over the engine-driven AC generators. When AC power is selected, the generator contactors will open and both bus tie contactors will close to allow AC external power to power both AC wound buses. An AC wound service bus normally provides power for high-draw items such as a galley and AC wound service plugs. Normally, the AC wound service bus is powered by AC wound bus 1 when the engines are running or AC external power is used. If the aircraft is unpowered, the AC wound service bus is powered by depressing the AC service bus push button on the flight attendant panel. This moves a contactor that connects AC external power to the AC wound service bus. The AC wound service bus powers non-essential items. Therefore, the AC wound service bus is automatically shed when one AC wound generator is offline. In the event both engine-driven DC generators have failed, a transformer rectifier unit, or TRU, converts AC wound power into DC power. This DC power then powers the DC system, which minimizes the draw on the batteries. In this situation, the TRU will be powering the DC emergency bus, the DC standby bus, the DC essential bus, and inverter 1. We will now take an in-depth look at the controls and indicators associated with the electrical system. Most of the electrical system is controlled by the main electrical power panel located on the overhead section of the flight deck. The DC generators are controlled by two push buttons labeled DC Generator 1 and DC Generator 2. When the push button is pressed in, the associated generator will be energized and the associated generator contactor will close provided the GCU determines that the generator output is within limits. Selecting a generator push button to the out position will de-energize the associated generator and the generator contactor will open. The off caption will illuminate to indicate that the associated generator is off. The fault caption illuminates in the event the GCU trips the generator due to a fault or if the associated generator contactor opens. You should note that if the contactor opens because the push button was selected to the off position, the fault caption will not illuminate. Regardless of what caused the fault light to illuminate, the bus tie contactor will close. This will power the affected DC bus to be powered by the operating generator. If the fault caption illuminated because the GCU detected an underspeed of the generator will reset itself automatically once the generator returns to normal speed. If the fault caption illuminated due to any other GCU protection, the generator would have to be reset by cycling the affected generator push button. The bus tie contactor push button controls the operation of the DC and AC bus tie contactor. As we just saw, the failure of one generator will cause the DC bus tie contactor to close, and this will allow the operating generator to power both DC buses. This will occur only if the bus tie contactor push button is in the released out position. This is the normal position for this push button. You should note that this push button is guarded to prevent accidental operation of the push button. If the bus tie contactor push button is pressed in, the bus tie contactor will open, and this will prevent any automatic powering of a DC bus with an inoperative generator. The isolation caption illuminates in the push button when it has been pressed in. The caption is white to indicate it is not the normal configuration. The external power push button controls DC external power. When the available caption illuminates, it indicates that the BPCU has determined that DC external power is of acceptable quality. External power is connected or disconnected by pressing the push button. The on caption illuminates when DC external has been selected. The DC service utility push button controls the connection of the DC service bus and the utility buses to the associated main DC bus. The normal position of the push button is the pressed in position. In the normal position, the DC service bus and both utility buses are powered as long as they have not been shed by the BPCU. Release of the push button out disconnects the DC service bus and both utility buses from the main DC bus. The off caption illuminates when the buses are disconnected. The shed caption illuminates when the BPCU senses an overload condition on one of the main DC buses and at least one utility bus is disconnected from the associated main DC bus. In addition to an illuminated shed caption, a single chime will sound, both master caution lights will flash, and the electric amber light will illuminate on the crew alerting panel. The DC bus off light illuminates when the associated DC bus is not powered. If a DC bus light illuminates, a single chime will sound, both master caution lights will flash, and the electric light illuminates on the crew alerting panel. The battery charge push buttons control the associated battery charger contactors. When the push button is pressed in, the multifunction computer controls the operation of the associated battery charger contactor. This contactor is normally closed, but the multifunction computer will open it in the event it detects the thermal runaway of the battery. It will also open a battery charge contactor if the associated DC main bus voltage is less than 25 volts, or if the main battery switch is in the override position. The multifunction computer will also open both battery charger contactors during engine start. The contactors will close when the start selector is out of the start or crank position. When a battery charger push button is released out, the associated charge contactor opens and the off caption illuminates in the push button. The fault caption illuminates amber when the multifunction computer detects a battery overheat or if the charge contactor fails to operate as commanded. In the case of an overheat, the charge contactor will automatically open. If one of the battery charge fault captions illuminate, the CCAS will be activated, and this will result in a single chime, both master caution lights will flash, and the electric light will illuminate on the crew alerting panel. The battery toggle switch controls the supply of DC power by the batteries. The power arrangement depends on whether the engines are running or external power is selected. In the on position, the essential bus, the standby DC bus, and inverter 1 are powered by the main hot battery bus, provided neither engine is running and external power is off. In addition, the emergency bus is supplied by the hot emergency battery bus. If the battery switch is on and either or both engines are running, or if external power is selected on, the essential bus is powered by the hot main battery bus, and the emergency bus and the standby bus are powered by the hot emergency battery bus. If the battery switch is in the off position, the essential bus, the DC standby bus, and inverter 1 are isolated from the hot main battery bus. In addition, the DC emergency bus is isolated from the hot emergency bus. In this condition, the only powered buses would be the hot emergency battery bus and the hot main battery bus. The override position bypasses the system protections and allows the buses to be supplied by the respective battery. This means that the system will remain configured as in basic mode. The BPCU keeps the standby bus connected to the essential bus and doesn't permit it to toggle over to the emergency bus. The override switch is primarily for use in the event of a dual generator failure when managing battery power is critical. A guard prevents the battery switch from being accidentally operated. Two amber flow arrows indicate when either one of the batteries is being discharged by either the essential bus or the emergency bus. The right arrow illuminates when the DC essential bus is powered by the main battery. The left arrow illuminates when the emergency battery is supplying the DC emergency bus. The undervoltage caption illuminates amber when the DC standby bus voltage is less than 19.5 volts. Normally, the override position of the push button would be selected in this situation. When the override push button is pressed in, the DC standby bus and inverter 1 will be powered by the sources supplying the DC emergency bus. When this position is selected, the override caption illuminates in the push button. The override push button enables the transfer of power for the DC standby bus and inverter 1 from the hot main battery bus to the hot emergency bus. When the push button is released out, the DC standby bus and inverter 1 will be powered by the source that powers the DC essential bus. The released out position is the normal position of this push button. When the TRU push button is pressed in, the TRU is connected to AC Wild Bus 2. This will illuminate the on caption. A white arrow illuminates amber when the TRU is supplying DC power to the DC emergency bus, the DC standby bus, inverter 1, and the DC essential bus. The normal position of the TRU push button is released out. In this position, and with one engine-driven generator operating, the DC emergency bus and the DC standby bus are powered by the hot emergency battery bus, inverter 1 is powered by DC bus 1, and the DC essential bus is powered by the hot main battery bus. If the TRU push button is in the normal position, and both engine-driven generators are not operating, the DC emergency bus is powered by the hot emergency battery bus, and inverter 1, the DC standby bus, and the DC essential bus are powered by the hot main battery bus. Battery charging is monitored by the DC amp indicator. This indicator will indicate if the selected battery is charging or discharging. The battery amp indicator selector, located under the indicator, is used to select which battery is connected to the indicator. The inverter fault lights monitor the associated inverter. A fault light will illuminate in the event an undervoltage or overvoltage has been detected at the output of the associated inverter. An undervoltage could be caused either by an inverter failure or a loss of power to the inverter. Regardless of the cause, the illumination of the fault light will result in a single chime. Both master caution lights will flash, and the electric light illuminates on the crew alerting panel. The AC bus off light illuminates in the event the associated AC bus is not powered. In addition to the light, a single chime will sound, both master caution lights will flash, and the electric light illuminates on the crew alerting panel. When the override push button is in the normal position, inverter 1 is powered by the same source as the one powering the DC essential bus. In addition, the AC standby bus will be powered by inverter 1. The normal position of this push button is when the push button is released out. Pressing the override push button in selects the override position. In this situation, inverter 1 is powered by the same source as the DC emergency bus. In addition, the AC standby bus will be powered by inverter 1. When override is selected, the override caption illuminates in the push button. The undervoltage caption illuminates amber when the DC standby bus voltage is less than 19.5 volts. If this caption illuminates, it would be appropriate to use the override position of the push button. The AC Wild system is controlled by the AC Wild electric power control panel located on the overhead section of the flight deck. The AC Wild generators are controlled by two push buttons. With the push button pressed in, the associated generator is energized. The associated generator contactor will close, provided the GCU determines that the generator power output is of acceptable quality. As you recall, each AC Wild generator is controlled by a dedicated GCU. If the AC Wild generator push button is released out, the associated generator is de-energized, and the associated generator contactor is open. An off caption illuminates in the push button when the generator is off. A fault caption will illuminate in an AC Wild generator push button in the event the associated GCU trips the generator to protect the electrical system from any faults. Illumination of the fault light will also trigger a CCAS alert. This alert consists of a single chime, both master caution lights flashing, and the illumination of the electric light on the crew alerting panel. The fault caption will also illuminate if the associated contactor opens for any reason while the associated AC Wild generator push button is pressed in. You should note that the fault caption will not illuminate if a generator push button is released out. If the fault was due to an NP overspeed that lasts less than 3 seconds, or if it was due to a generator underspeed, the generator will reset itself automatically. For any other faults, the generator can only be reset by cycling the affected generator push button to off and back in. In the event an AC wound bus is unpowered, you will hear a single chime, and both master caution lights will flash. In addition, the electric light illuminates on the crew alerting panel, and the affected AC wound bus off light illuminates on the overhead panel. The bus tie contactor push button controls the operation of the bus tie contactor that ties the left and right AC wound buses together. When the bus tie contactor is closed, the two buses are powered by the operating AC wound generator. The normal position of this push button is when the push button is released out. With normal selected, bus tie contactors 1 and 2 are open, and the two AC wound buses are powered by their respective AC wound generator. With normal selected, the two bus tie contactors will close when only one AC wound generator is operating or if AC external power is being used. The closing of the bus tie contactors is indicated by a flow bar in the bus tie contactor push button. Pressing the bus tie contactor push button to the in position selects the isolation mode. In this mode, both bus tie contactors open and will remain open even if one AC wound generator fails or if AC external power is used. As discussed earlier in this module, the DC service bus can be controlled by the DC service bus push button on the cabin attendant panel. Placing the push button to the in position will power the DC service bus if a power source is available. In this case, the on caption will illuminate blue. The DC service bus is depowered by releasing out the DC service bus push button. This will cause the on light to extinguish. The shed caption illuminates whenever power is available on the aircraft and the DC service bus push button is released out. The caption will also illuminate in the event the DC service bus is shed in the event of an overload condition. The ground service bus AC wound push button is similar to the DC service bus push button. When the push button is pressed in, the AC wound service will be powered whenever AC wound power or AC external power is available. In this case, the on caption will illuminate in the push button. The AC wound service bus is depowered by releasing out the AC wound service bus push button. This will cause the on caption to extinguish. The shed caption illuminates if the push button is released out and a source of AC wound power is available, or in the event the AC wound service bus is shed due to an overload condition. The lateral maintenance panel incorporates 3 gauges that display the voltage load and frequency of AC power. A rotary selector is used to connect a specific AC power item to the gauges. The generator position selects one of the AC wound generators. An AC wound bus tie contactor selector allows maintenance to force open one of the 2 AC wound bus contactors. The switch is guarded to the normal position. In this mode, the AC wound bus tie contactors will function according to the system logic.